sharing my, hold on. Okay, I'm going to start by sharing my screen. So give me just one moment. And of course that meant that, one second. What is a workshop without technical difficulties, honestly?
Exactly.
And actually, I want to make sure everyone has access to this presentation, just in case you'd like it. So I'm also going to share that in chat. And all right, I'm going to share my screen now. Can everyone see my screen?
Yep.
Fantastic. All right, I'm going to present. Can you see the presentation?
Yes, clearly.
All right. Is it full screen? Did that work? I'm gonna just make sure. Excellent. All right, so thank you everyone for joining. I'm Mariel. I'm a senior curriculum developer at Codecademy, like Nagar mentioned. You can follow me on Twitter at Mariel's Musings. And I'm going to be using a repo that I actually put together for PyData New York 2019. When I initially created this presentation. So if you want to check out that GitHub, you're welcome to. Some of it seems like the spacey portion is a little bit outdated. So at some point, I'm going to have to go ahead and update that. But the Nltk files work just fine. So just quickly on the agenda, we're going to go over what NLP is, how it's used. We're going to get a chance to try out some text pre-processing. I was hoping we were going to get a chance to try out some parsing, but that may be on pause for today. We're going to learn a little bit about language models, which is also known as language quantification, sometimes even referred to as feature engineering for NLP. Some current applications or use cases, as well as challenges and considerations. And then we'll have some time for Q&A, so you can ask me whatever you'd like about that. So just a quick poll, if everyone wants to go ahead and go to pollev.com/MarielFrank845. What is NLP? What do you think it is? You can just add a line or two, whatever you're thinking. And what I'm going to do is pop in here. And we should start to see this pop up on this screen. So as folks submit some answers, we should see that pop up here. And don't be afraid, it's like not, it's not, I'm seeing some stuff in the chat. Oh yeah, really good point. Let me do that.
Oh, I did it actually.
Oh, you did? Even better. Thank you.
I think it requests access.
It's requesting access.
Yeah, I think.
Interesting.
Yes, very interesting.
Let me see. It says it's active. It should be showing responses. Oh no.
Technical difficulty. Here we
go. Of course. I did this a while back. It worked without problem. And the audience can respond in this activity as long as the activity is active. So strange. All right, if people want to just pop it into the chat, I can probably add some responses on my own for folks. I know it's not quite as cool, but it'll be something. Yeah, I'm actually logged in as the activity owner. I don't know why it isn't working, but
Yeah,
thank you.
error.
Thank you for submitting a response to Nagar. I'm adding that one in. We should just start to see some text pop up there. And should see some more stuff pop in here. And for whatever reason, I'm only seeing that first one. I'm refreshing. All right. I was hoping this was going to make a really nice word cloud. It's worked before in the past, but even taking a look at the way that people are responding in chat, we can see some trends. So we're seeing, something to do with text and speech, language, human, there are some words that start to pop out here. And what I'd like to show you is NLP is an entire domain. So it is concerning language, it is concerning humans, and it is concerning computers or math. So it's this domain that's sort of a hybrid at the intersection of linguistics, AI, data science, and computer science. And the goal is really to enable machines to interpret, analyze, and generate natural human language. The origins really come out of the 1950s when Alan Turing developed the Turing test and said, okay, if we're thinking about artificial intelligence, one of the metrics that we want to use to measure whether or not something actually fulfills an artificial intelligence is its ability to deceive humans into thinking that it's human. So one of those facets is by creating language. So if a computer is able to generate language that comes across as human to other humans, it's successfully going to be considered an artificial intelligence. At the same time, there were all of these advances within machine translation that were coming about around the same time. So, I think a lot of that actually came out of the Cold War and efforts to kind of translate back and forth for spies. But it's interesting because these two disparate areas of NLP started to come together within the 1950s. So, quick question. Have you used any NLP applications today? What do you think? What are some that you've used, or do you not think you've used any? Feel free to respond in the chat. All right, Google Voice. Grammarly. Siri. Anything else? Does anyone think that they haven't used any NLP applications today? Search engines. Yep, absolutely. Yeah, so probably everyone here has used an autocorrect. Yep. A lot of code, absolutely. You've probably used NLP today. It would actually be surprising. Maybe you didn't if you just rolled out of bed and immediately joined this conference without actually typing anything into your computer in the process. That is the one way that I can imagine that you have not used any NLP. It's in spell check, it's in autocorrect, it's in auto-generated video captions, it's in virtual assistants, like you mentioned, search engines, autocomplete, including autocomplete for code, spam detection, your news site suggested articles. It's really all over the place. So I think a lot of folks don't realize how pervasive NLP is in everyday life. It is just everywhere. It is ubiquitous. So let's go through some areas of NLP that we can focus on. So the first thing that you do before you do pretty much any activity within any field of data science is any kind of data preprocessing. And that's true of, you know, numeric data, tabular data, any kind of data. And NLP, being a cross-section with data science, also cares a lot about preprocessing data. One of the things that's really common to do is noise removal. Another thing is tokenization. Another thing is normalization. So what do these things mean? So noise removal is the idea that you want to take anything out that isn't necessary. So maybe you're taking some kind of, you've scraped the web and grabbed a bunch of text from a website, but it has a lot of weird extra characters in there. There's some, side notes, there's captions to images. There are a bunch of features that you don't actually want to include within the data that you're looking at. So when you take that away, that's considered noise removal. Tokenization is usually going to be at the word level, but it could be at the at longer strings of text level, but usually it's at the word level. You want to break your text up into words. So for some cases, this isn't going to be necessary, but for a lot of cases, you're going to be breaking up your text before you do almost any other activity within NLP. Normalization can be broken down into a few different components. So one of them is stop words removal. So if you want to remove really common words, let's say that you're doing a task where you want to understand a specific topic, like if you want to really get a sense of what the topic is of a particular piece that you're looking at, then you might want to remove words that aren't very necessary. You know, common words that occur all over the place. Like in English, we have the, and, for. I mean, the list goes on. There's an enormous list of stop words in English, and I'm sure that's true of a lot of different languages. So that's one facet of normalization. Another is actually uppercasing and lowercasing. So if you want to look at text, you don't want to have capital the be different from lowercase the in a lot of situations. You want those to be the same word. And the same would be true of like my name. Maybe sometimes people spell it uppercase. Some people will spell it Mariel and it'll have like a heart at the end. Regardless, all of this is part of normalization. If we have it all lowercase, if we have it all uppercase, we want it to be the same. So you want to standardize your text by either making it all uppercase or all lowercase and removing any kind of characters that aren't necessary. Stemming and limitization. So these, I don't know of any good libraries to do this outside of a few languages. So I'm just going to throw that out there. Nltk supports some languages, but not many. And this is actually a problem that we'll be talking about later, which is within challenges and considerations within NLP at this point. If you know languages other than English, please do more work in NLP. Please create more NLP tools. I'm going to throw that out there. But stemming and limitization are when you truncate words down to their roots. So stemming is the fast, easy, blunt way of doing this. And for a lot of use cases, it'll be fine. But for some use cases, you really want to consider what the part of speech is, and from there actually be a little bit more fine-tuned in the way that you cut things down. Some common libraries that you'll encounter if you're doing text preprocessing include regex, or regular expressions, Nltk, which is the Natural Language Toolkit, and we'll be using both regex and Nltk today. And then pandas is also really common because it's bled over from the data analytics and data science domains. Before we get into the rest, do you have any questions?
I think everything is clear.
All right, fantastic. So with that, I'm going to share, what is data preprocessing? That's fantastic. That's a really good question. So just like with text, you need to kind of clean up your text and put it into some sort of like standard order before you work with it for a particular task. You need to do the same thing with other types of data, whether that's numeric data, whether that's time data, whether that's geolocation data, and the list goes on. There's spatial data, et cetera. But the point is, for any kind of task within data science, within data analytics, within NLP, you need to do something with your data ahead of time to prepare it for whatever that task is. So that's really what data preprocessing is all about. And that is considered a step before. What about the losses we might face? That's a really fantastic question. The losses we might face while preprocessing. So this is why it actually really matters what the task at hand is. If you are planning on doing a text generation task, you probably don't want to be doing any kind of stemming or limitization, because you don't want to lose your endings. You also probably wouldn't want to get rid of stop words, because stop words are an incredibly important component of your text. So if you removed all of your stop words, you'd just end up with words that are, they have some meaning, but if you removed all of them, you wouldn't be generating text that sounded anything like natural human text. So that's a really great question. Yeah, there are going to be losses, and that's why it's really going to be task dependent what kind of text preprocessing you want to do. So one thing I wanted to share, I don't know whether, why are you starting? Okay. Did folks get, I wasn't sure, Nagar, did you get a chance to send out the GitHub link ahead of time?
Not really, no.
Okay, no worries. I'm going to send this out in case folks want to follow along in a bit of a walkthrough of some preprocessing. So this might take a moment to load. And we're really only going to focus on the preprocessing piece of this. But I'll give you just a moment so you can pull this up if you're interested. And even maybe take a moment to just look over what's on my screen if you're not planning. Binder is inaccessible. What? No. This is just like every possible kind of. Hold on. Let me see if this works coming out of here. There's also a link to the binder through here. So if you scroll down, it should say launch binder. Languages like German, where the words can be capitalized or not, like sprechen and sprechen. Are there any special tools for such cases? That is a really great question. Unfortunately, I have mainly worked with English text. So I don't know the specifics of how tools cater to specific languages. I would hope that there are ways of, dealing with those two words separately within a language like German. versus in a language like English. I don't know whether that's supported within NLTK at this point, but this is actually really underscoring like why it is so incredibly important for folks who are not, who speak languages other than English to work with languages other than English, and create tools that support languages other than English. Because NLP should not just be about English. There's just way more support for English at this point, but there should be way more support for other languages as well. That's a great question. Were folks able to open this link, this particular binder link? Did that work? Tushar, I noticed that you mentioned something about that. I don't know whether you were able to access it through the GitHub.
Yeah, now it's fine.
It's working? Okay, that's good. Fantastic. Okay, so once you're in there, if you can navigate over to preprocessing and onto the text preprocessing notebook, I'm gonna open that up. Yay, glad to hear that. All right, you can go ahead and run that first cell. So what this first cell is doing is importing the regular expressions library for Python. And regex is useful for finding and also for a lot of like find and replace activities that you might want to be doing. So NLTK, for some pre-processing wonders, we're going to be including word tokenize so that we can tokenize our text, like I mentioned. We're going to be using the Porter stemmer. We're going to be using the WordNet limitizer so that we'll be able to see the difference between what a stemmer can do versus what a limitizer does. And we're also, as I mentioned earlier, we're going to be breaking our text up into individual words, which is what the tokenizer is going to be doing. So we're going to import that. And we're going to import NLTK so that we can grab a few specific corpora. So we're going to be downloading punct, WordNet, and stop words. And you should see output true if everything resolves correctly. So the next piece is actually just a dummy piece of text that I grabbed through the Looking Glass. Alice, or it's like the sequel to Alice in Wonderland. You can actually replace this if you're curious with another piece of text. It could be an email, it could be something from the chat over here, whatever you're interested in taking a look at. So I'm going to run this with this text, but you can replace it with whatever text you're interested in. So the first thing we're going to do is we're going to clean this up by getting rid of any characters that aren't words. So for example, this hyphen right there, this comma, these are the kinds of things that are going to be replaced. Colons, periods, etc. So any kind of punctuation is going to be replaced there. Right. So you can see this is cleaned up now. We are free of punctuation. So now the next thing we're going to be doing is tokenizing the text. So we're going to, as I mentioned before, split this text up into individual words. It does it quite nicely, quite quickly. You can see that each of these we now have a Python list that is a full string, like sorry, it is a Python list of strings. So each element within the list is just a string. And next up, we're going to be trying out the Porter stemmer. So what we're hoping to see is for all of these different words to be chopped into what the root of the word is. So for example, if I have something like seemed, what I'm hoping to see is that this goes down to seem. If I have looked, I'm hoping this goes down to look. If I have crowded, it might stay crowded, it might go down to crowd. Exactly might go down to exact. These are the kinds of things that we're hoping to see. So let's test it out. And what we're doing is we're calling stem on each token for each token in that tokenized list. And what we see is we now have, this is interesting. So curio for curious. So I don't know if this is starting to show you something. We have whenev for whenever. We do have look for looked. We do have crowd for crowded. So we're starting to see there's some of these that it seems to be getting right, but then we have this weird one right here. We have exactly instead of exactly like this. So what's that about? This is sort of interesting. So what's happening is the Porter stemmer sort of automatically treats everything like a noun. And I'm pretty sure the limitizer does this as well, but the Porter stemmer just like lobs things off in just whatever manner it thinks is going to be most efficient. So you end up with these weird situations where, like, you know, whenev, it might be treating whenever like it's actually an adjective. So it would say something like happy versus happier. So it's lobbing that little like ER off because it thinks that it's actually a comparative adjective. So it needs to get rid of that ER to get down to the root. It is able to see things like seem versus seemed, but then, you know, maybe it thinks that curious is actually, it's taking that S off because it thinks that this is a plural noun. So it's taking it down to a singular curio instead of multiple curious. You can see this is efficient, but there are issues here. Now, a Lementizer, on the other hand, does some things differently. So let's try that out instead. So we're going to go back and we're going to use that original tokenized text from up here. We're going to leave this alone, this stemmed text. All right. We can see that curious is left alone. We can see that whenever is left alone. But we still see something that's interesting, which is something like was is wa. And we see that, where's another interesting one? We still have others, which is interesting, instead of bringing it down to other. But we do have exactly spelled out the way that we would expect, as opposed to having that I at the end. But we actually almost have too much here, because oddest should really go down to odd. We should see some of these lobbed off a little bit more. But what's happening here is that the limitizer is being a little bit cautious in a lot of ways, because it's going to treat everything like it's a noun. That's the default. But we do have this little get part of speech function that we built out here, or I should say, I built out with the help of a whole bunch of Stack Overflow research, which is going to say, okay, let me look through WordNet which is the corpus that we downloaded from NLTK. And we are going to find out what like the most likely part of speech is. So we're going to be using counter to like find the way that it is generally mapped, like if it's usually a noun, if it's usually used as a verb, if it's usually used as an adjective or as an adverb. There are more parts of speech that exist. We could have a much, much longer list, but we're really only going to stick to nouns, verbs, adjectives, and adverbs for this. So from there, what we're going to do is we're going to get the most common part of speech that it returns, and we're going to take that and use it back over in here so that we can say, we can pass into the lematizer not only the token, but that specific most likely part of speech. So that way the lematizer is a little bit more information to work off of, and instead of just defaulting and saying, okay, this is probably just going to be a noun, let me just leave it at that, you can actually say, no, hey lematizer, this is actually an adjective, treat it like an adjective. So we can try this out. We're going to import that function. And here we can finally see that we end up with something that makes a little bit more sense. We bring crowded down to crowd. We bring, what were some of the other ones that we were worried about? We had, I think, oh, was going down to be instead of going to wa. We have curious is of course left alone.
Where is be?
Sorry?
Where now is be. You didn't mention that.
Be?
Yeah, where and the lematizer and the nouns.
Mm-hmm.
Yeah.
Where in the nouns is be?
Yeah, and the 11th line.
On the 11th line.
Yeah.
Oh, so what would happen is was from way back up. Are you talking about this part where was turns into be? So was would be passed in, where are we, as a token, along with what would probably get returned as a verb. So then it would recognize that wa is not the singular of was, and instead was is a verb, and in fact, the root of was is the verb be. So from there, it's able to make that prediction. Does that all make sense? Do folks have questions? I know this is a really weird facet of text preprocessing. Okay, I see a couple of questions. Before removing these bits with the stemming, is it useful to use them somehow to not lose some information? So it's always going to be task dependent. If you have a task where stemming is just not the appropriate way of pre-processing your text, then you don't need to do that. If you're curious to see whether stemming is the appropriate way to pre-process your text, you can always try it out. And I mean, the nice thing is, you know, with Python, you can always create things under a new variable. So you can go back to that original data set or that initial preprocessed before the actual stemming portion of your preprocessing, the stemming portion of your preprocessing, to go back and say, oh, actually, I wanted to lematize this instead of stem this, or oh, actually, I don't actually want to do any of this. I'm going to go back and use that original variable that stores that nice tokenized list and do something else with it. So why not use the lematizer with part of speech directly? If it's so efficient, why go the stemming route? Yeah, it's again, it's going to be task dependent. For some tasks, the stemmer is actually enough. It really depends on what you're doing. So, oh, just to clarify, I was saying that the word were is now be, which is cool. Oh, yes. Thank you for pointing that out. I didn't even notice that one. Yes, were is also now be because it recognizes that. Thank you for pointing that out. Yeah, if folks have other questions, you're welcome to ask. The next portion of what I wanted to demonstrate is just some stop words removal. There's a list of stop words that Nltk actually has, so I can grab that and you can see what that list looks like. So it's stuff like I, me, my, myself, we, ours, how, all, any, both, is, doing, did. It's a lot of words that don't give us too much information, especially if really what we're trying to do is pull out a particular topic. And I can filter my text for that. So, you know, I can say word for word in tokenized if the word lowercase is not in this list of stop words, and I can filter it that way. So you can see that actually it brings this list down by quite a bit because there's a bunch of things like to and be and the, which are all going to get cut out. Do folks have any other questions? If we're good, I'm going to move back over to the presentation. Okay, so parsing is another task that you might do within NLP. One of the reasons that you might be parsing is to find something specific. So parsing, I like to think of as a little bit like detective work, where you're hunting down something specific, but you don't know quite what it looks like. So you might know that what you're looking for is a noun followed by an adverb followed by a verb. And that might be all you know that you're looking for. So you're trying to find that specific pattern throughout your text. And that's something that you could use parsing for. So you can parse by part of speech. So you might want to go ahead and like tag all of your text with a particular part of speech. You might want to use some named entity recognition where you're recognizing specific proper nouns. You might want to do some, you might want to use some dependency grammar where you're able to use the computer to kind of figure out for you what the likely configuration is within a given piece of text, like whether something specifically is the subject versus the verb, or versus the object in a given sentence. And having computers do that for you might speed up some other facet of your work. So some common libraries that you might encounter for this, regex again, Nltk does some of the lifting for you, but also Spacey is really, really helpful here. And just to give you a sense, like English, I mean, I'm sure all of you are familiar with like English is incredibly ambiguous. Sometimes it is really difficult to tell what somebody is talking about or what they're trying to say. So if I say a sentence like, I saw a cow under a tree with binoculars, am I saying that I had the binoculars? Am I saying that the cow had the binoculars? Or am I saying that the tree had binoculars? In English, this is actually completely up in the air. It is not clear what of these things is the case. Now, of course, we as humans can always kind of figure out from context some of this, or like the most likely scenario. but a computer can't. So trying to like help a computer make sense of that is one of the real tasks that you end up going into within parsing. For a lot of tasks, what you're going to be needing is a language model, or some form of language quantification, or as I said before, this is also known as feature engineering for NLP. One of the most common types of language models is called bag of words, which is also known as a unigram model when it's kind of talked about in relation to the Engram model. TF-IDF is a way of sort of inverting a lot of what you do with bag of words. So let me back up for a second, because I just threw a whole bunch of vocabulary at you. What are these things? Okay. What language models are hoping to accomplish is have some way of translating human words into computer features so that we can do something with it. So a lot of the time what this looks like is translating text into vectors. So we want some way of saying, okay, represent the word the with a number. How is that going to be represented? And maybe it's only represented as a 1 within this particular context. Within bag of words, really all we're doing is we're just trying to say, okay, count how many times each word appears in a given document or within a given piece of text. So like you might notice in this GIF that I have here, we have this really weird sentence, the squids jumped out of the suitcases. What we're trying to accomplish here is we want to know how many times each of these words appears. So we can see that the appears twice. So bag of words will tell us the appears twice. Bag of words should recognize that something related to squids only appears once. Something related to jumping also only appears once. Out only appears once, of only appears once, and suitcases only appears once. But with a lengthier piece of text, I'm sorry. With a lengthier piece of text, you might have more going on here. And actually in the Codecademy natural language processing course, you can find a way to kind of like play around with this with whatever given piece of text you want and have it represented visually in front of you. TF-IDF is a way of taking, instead of bag of words, looking at only specific words that don't appear across all of your text. So if you want to look at like a bunch of documents at the same time, and you want to find out what is actually important to each specific document, then you don't want the words like the and that appear across all of those documents. Or if you're looking at medical texts, for example, you might not want the words like doctor and medicine coming out as the most salient, because each of these individual documents is actually specifically focused on a particular piece of medicine. So that's what you really want to hone in on. Engrams is another way of doing some of this representation where you this is sometimes useful if you want to do some text generation and you don't want to screw around with neural networks quite yet. Engrams allow you to chunk all of your language into pieces. So you can almost think of your language as like a collage where certain phrases always occur and they kind of overlap with each other. And for each given sequence of words, you might have several different directions that a given word is going to go in, or that a particular sentence is going to go in. So after saying the, like, or after saying, I ate the it would be pretty weird to hear me say like penguin. You'd probably would expect me to say something more likely like sandwich. You know, you really are going to start to expect certain patterns to exist within language. So what Engrams does for you is it gives you a list of probabilities for each of those given words within your corpus. Word embeddings, we'll get into those a little bit later, but they are pretty neat. They give you a sort of spatial vector representation of language. Some common libraries that you might come across, Nltk again, Spacy again, but now we can get into some of the machine learning libraries like scikit-learn, TensorFlow, and PyTorch all allow you to do some kind of feature engineering or language quantification. There are, as I mentioned, also neural language models. Some really common approaches are using LSTMs, which are long short-term memory models, which are way more complicated than what I want to get into within the confines of this particular workshop. But they basically allow you to work with text in sequence, retaining a little bit of the previous information. And then transformer models are getting more and more used. They usually retain a whole, it's usually a pre-trained model that has a bunch of information already inside of it before you even start to train it on your particular data set. By the way, I'm sorry if I'm going way off the deep end here. Please ask any questions that you have at this point. And Ahmad, I'm really glad to hear that you think this is interesting. So some common use cases, like I mentioned before, word embeddings. Here's an example of a word embedding in that image with king, queen, man, woman. There's another one over with walking, walked, swimming, and swam. So these are ways of sort of representing language in space. So what I would actually be able to do is say that in vector space, the vector for king, subtracting the vector for man, adding the vector for woman should give me a vector that is really, really close to the vector for queen. And this blew my mind when I found this out. I was like, wow, we can do this with language. This is so cool. Computers can actually come up with a visual mapping, a spatial visual mapping for where all of these different words exist. I noticed that the bag of words had the plural S of the words removed. Do these language libraries know the difference already? That is a really great question. So a lot of the time, I mean, it's going to depend which library you use, but usually when you're doing bag of words, you're going to want to do some kind of limitization so that you have, you know, something like king and kings both counted as the same word rather than as separate words. So you would probably want to do that before doing a bag of words approach, but that's a great question. So we can store those transformations and reuse them. Avinash, are you referring to the king minus man plus queen plus woman equals queen or something earlier? Yeah. Yeah, Word2Vec is a pretty cool way of doing word embeddings, and I highly recommend checking that out. It's pretty easy to do using Spacy. So I would check out the Spacy library for that to find out how to do, I think they have it as Tokenization, referring to tokens. So I'll just type that in so you can see what I'm talking about. So yeah, please look into that. It is such an interesting facet of NLP. Another really common way of exploring language is looking into text similarity. So this could be something like semantic similarity, where we want to see whether two particular pieces of text have topics in common. It might be something where we are trying to make sure that somebody isn't plagiarizing. So it could be that we're looking for specific chunks of text appearing in one thing and in another thing. So we're really looking at how similar these pieces of text are. And it could be something where we want to see, does this look like it's the same style of writing? And these are the kinds of things that computers can actually help us out with. There's actually a pretty cool, in the NLP course, we have a project focused on email classification and trying to figure out, using bag of words, whether an email was written by one person versus another person. And naive Bayes will allow you to make that prediction one way or another. And it's actually pretty freaking accurate, which is cool. You can get into sentiment classification and analysis. So you can find out whether something, whether people appear happier or more upset. This is something that social media companies do a lot. They want to track their users to see whether they are, whether particular types of content will affect their users in one way or another, and how. I know that there was this whole experiment that Facebook ran at one point where they were specifically trying to, they did like an A/B test with a bunch of their users and tried to see if they showed folks more upsetting content versus happier content, how their users would interact with the platform. Bias detection. So this is something that's getting more and more important, especially in the tech world right now. Tech companies want to make sure that they are less biased. So they try to figure out ways of detecting bias within all of their processes, within anything that they're doing. And you might also want to take a look. There's actually this pretty interesting blog post I found where there's a whole analysis of Harry Potter to see whether there's a little bit of gender bias going on there in a particular way. So there's this incredible analysis that's done by somebody who has a kid who's reading Harry Potter, and they had this kind of gut feeling that there was something going on. So they used some parsing techniques to dig into bias detection, and they came up with some interesting results. Predictive text. So you probably have noticed, Google, especially if you're using Gmail, will start to write your emails for you. That is absolutely predictive text. Google at this point is using transformer models, but back in the day, they were playing around with just some basic Engrams to see whether they could figure out how to make predictions. And that also goes for any kind of autocomplete when you're typing into a search engine, whether you are writing a text message and get suggested next pieces of text. All of that is part of predictive text. Machine translation. Anyone who uses any kind of like Google Translate, anything like that, all of that relies heavily on neural language models. And language accessibility. So, as we want to make the internet more accessible to more people, and computers and just any kind of technology more accessible to more people, text to speech, because it becomes incredibly important for folks who are visually impaired or blind. Speech to text becomes really important as well for them. Having some way of translating from video and just automatically generating captions, all of that relies heavily on work that has been done within NLP. So some challenges and considerations, which I mentioned earlier. So I like to say with great language processing comes great responsibility. We all have accidental biases, these exist. When, as much as technology might be neutral, the data is not going to be neutral that we use to train our models. The way that we account for particular exceptions to particular rules, all of that, as we're generating a model, we have our biases. It's in our data, it's in the way that we code, it's going to be there. We need to kind of check ourselves and make sure that we are not adding too much in, and also trying to validate that it actually is doing things the way that we, what abuse can come from this, in your opinion? A lot of things.
Sorry.
Yeah.
I'll read the above comment first.
The above comment. I find it super useful to society, but sometimes it seems a bit like Black Mirror. Is there any legislation of technology to protect the people from abuses? I wish there were more legislation. Oh my goodness. There really isn't much. Governments really have not caught up. Yeah. Governments have not caught up to everything that large technology companies have been on top of. I know at least in the US, there have been lots and lots of pieces of proposed legislation from folks, I think specifically focused around privacy, focused around computer vision. I don't know how much has been out there for, I mean, we have so many issues, but unfortunately, very little has been passed, at least in the US. I don't know how much worldwide. I haven't heard about any governments being particularly proactive or particularly on top of these issues, which is really unfortunate. And I think a lot of the time it falls on us as folks who create this technology to really pay attention and to bring awareness to these issues to folks who could potentially have an impact on legislation. It would be wonderful if governments were a lot more on top of this. Yeah. Thank you for that question, though. Privacy and transparency issues with many NLP applications. Like I mentioned, privacy and transparency is, well, I mentioned privacy. Transparency is another issue. We aren't necessarily transparent about the data that we collect. I don't think Google is particularly transparent about how much data they're collecting. I don't think any social media company is particularly transparent about how much data they're collecting. And, they, as much as they might say, oh, we're not going to be using it for any nefarious purposes, we're, do no evil, et cetera. Who knows what that company might turn into in the future, who might buy that company, how that company might split off and still have that data and be bought by another company. All of these things are concerns, considerations, or even, maybe we don't want the government even having access to all of that data. And that's something that the government might be able to have access to. I know this is a particular concern in China right now, where the Chinese government has incredible, they are able to see everything that goes on, and they can collect all of that information as they please. Privacy is not a thing there. In that case, at least there's some transparency. They are transparent about the fact that they collect all of that information. In the case of a lot of US big tech companies, that's not necessarily the case. They're not necessarily transparent about how much data they're collecting. You know, is your phone company being transparent about how they're using your data? All of this is a concern and definitely something to consider as you work with text data sets. Another big consideration is language variation. So as I mentioned before, most NLP tools have really been created for English. Almost everything is focused on English. But the truth is, like, NLP, that it should be for languages across the world. We should be able to work with languages that affect everyone, not just English. So the more that folks who are native speakers of other languages can work with NLP, develop tools specifically for NLP, I think the better this field is actually going to be, rather than biasing completely towards English and even really specific variations of English. And kind of on that note, Spacey and Nltk really support really few languages at this point. If you take a look at what languages they support, you know, the closest one, like Georgian is not on that list. Russian is, but that's one of a very small handful of languages. And then another thing, and this is more of just a, you know, as you're trying to make sense of the text that you have, there's slang. Slang is oftentimes not really encoded properly. A lot of models have not been trained on slang. So how does that impact the results that we see? So I'm gonna go back to the chat, take a look. I saw something pop up. Aren't there laws just regarding the data collected, regardless of what kind of data or how much data is collected, generalizing laws on data itself? Yeah, that's actually a really good point. The European Union has a pretty strict law governing data collection and privacy, but I don't think that many countries do. And I know for sure that the US does not, aside from California. I think that's the one state. I'll have my team get back to you, right? So true. Yeah, it is such a weird world out here. Okay, so anyway, I know that I think we have even more time than what I budgeted for, which is cool. So we've enough time for folks to ask as many questions as they like. And if you're curious, like if we want to spend the extra time, I can start to go through a little bit of the Codecademy NLP intro course with you.
Yeah, actually, that was gonna be like my question. Like, can you show us what NLP stuff is there in Codecademy?
Yeah, absolutely. So there are two major areas that we have natural language processing. One is a skill path called Apply Natural Language Processing with Python. And if you just do a search in the search bar for NLP, this should pop up. A lot of what we went through today is covered in, not there, sorry, is covered in this first lesson right here, getting started with natural language processing, although there's even more here. But then there's a lot more exploration into text preprocessing, language parsing, language quantification, text generation. There's also a portfolio project that you can try completing. There's also codecademy.com/learn/build chatbots with Python. So I know you mentioned earlier, oh, that did not go where I was expecting. Let me find this. There is a skill path completely focused on building chatbots. And then there's actually one more place that you'd be able to learn a bit, which is in the Alexa courses. The one caveat I would say is the Alexa courses are really, they're less NLP focused and more focused on specifically using Alexa commands and programming like really specific inputs for Alexa. But there are these two Alexa courses if you're curious. So there's Learn to Program Alexa and Learn Conversation Design with Alexa. But if you're interested in doing things in Python, go into Path menu, and go back to the beginning.
Can I just add something? Yeah, so I started learning, NLP like a year ago. And well, I did the Stanford online course, which is like a very good one, but it really took me a long time to actually have hands-on experience. But when I found Codecademy, it's like literally you're coding. Like there is no video, there's no nothing. You just go straight into coding. So I think that's what makes it special. I just want to add that.
Yeah, that was really my intention when I was building the Getting Started course out, because I felt like the materials I was finding for any kind of level of introduction was so heavily theoretical, so heavily focused on the math, and really didn't give you an opportunity to play around with the code itself, which is, I think, what gives you that spark of excitement, that ability to actually work with the code itself and see results. So yeah, even in the very second exercise, this is essentially what we went through today, text preprocessing. You're really able to just dive in, play around with some code, change it as you like. In parsing, you can create a dependency tree. You can see some of the work represented visually in front of you. It's kind of fun. With bag of words, you can see the list of words, and then you can see how they get mapped to particular numbers, which is the count for each of these. So we have Humpty and Dumpty, both 19 times, staying 19 times, Alice 16 times. Again, I was using Alice in Wonderland. In Engrams, we can see like why particular numbers of Engrams make sense. You can change the number of Engrams and play around and see how that changes the output as you're trying to generate text. Oh, I haven't gotten to never mind. That's in text generation. This is just when you want to take a look at how often of the occurs. It occurs 101 times. Said the occurs 98 times. And you notice again why that particular patterns are going to exist. A lot of the time they're going to be something that you would see anywhere, something like of the, but some things you might see that are going to be specific to this particular document. So the queen probably isn't going to be everywhere, but it's specific to this document. And then you can get into trigrams, so you can get into strings, or sorry, three tokens in a row. And you can play around and see, like what happens if you want to list Engrams going up to like 5 words in a row. How often do you see the same 5 words in a row? Sorry, I'm just going to go back to the chat again. protests in Colombia. Facebook took down the posts with the Renaissance tools completely arbitrarily. Text generating tools that are used to scam people. Yep, definitely. Yeah, the features, we use so many NLP tools daily. It is just daunting once you realize it. They are just so ubiquitous. They're everywhere in our daily lives. And the vast majority of people I've spoken with have no idea what natural language processing is. They've never even heard of it.
Yeah, I just want to add something else that I think everyone has heard about GPT-3 here, which is like ultimate OpenAI API, which I actually recently got access to.
Yeah, it's fun, right?
Yeah, it really is. I just wanted to say, like, it's gonna get worse from here. Like, we're gonna have stories and fake news and poetry even, which so just expect things to get worse, I would just say.
Yeah, I mean, interestingly, GPT-3 is, you know, it's kind of created with the intention of not making things worse, but yeah, exactly. It's still a trained model. It still has biased data. It's going to be used in nefarious ways, and we really don't know where things are going to go. And I hate sounding like a Black Mirror episode, as someone mentioned earlier, but it's a lot to consider. And I mean, it's a lot of power you realize that you have as you develop tools with natural language processing. Yeah, so we can get into, there's a lot with topic modeling and text similarity. There's kind of a cool tool called edit distance, which uses what's called Levenshtein distance. And you can check, you know, how far apart two given words are. I actually really wanted to include, if you do a search into Levenshtein distance, I don't know if I would recommend Black Mirror. It is a lot to take. Let me see if I can find one that actually makes me, yeah, okay, here we go. So if we look at the distance between Google and look at, you can see, you know, how far apart each individual thing. Actually, what's a better one? You can do this with all kinds of words. Okay, so you see that like H and H are the same. So they're 0 apart. If you have a space beforehand, that would shift, you know. Anyway, it's pretty cool. I definitely recommend looking into Levenshtein distance a little bit. It's a very, very cool algorithm. But it's able to, you know, tell you how distant apart two words or strings are. So this is really, really useful for something like autocorrect, or, you know, any kind of spell check type tool. With language prediction and text generation, this is pretty fun. This is using a Markov chain and Engrams, and you can train it on as much text as you like. I kind of went with this Alice in Wonderland theme again, but you can actually play around here and just pop in 3 different documents to use to train, and then you can generate something that will look a little bit like the text that you passed in. So if I change this to something else, let's say, grab random text. Probably not lorem ipsum. Sure, let's go to Imaginary Friends Reunited. Betty, I don't know. I can grab this, I can pop it in here. Just did that wrong, apologies. So this looks like this is going to generate something that sounds like kids' speech. This is, by the way, what I'm doing right now is I'm saying to train this on much smaller quantities of text, but maybe we'll get somewhere with this. Find something a little bit longer, if possible. Oh. Bear with me. This is probably going to sound pretty specific because I am running something that doesn't have, what? Training doc 1 is not, oh, there we go. Let's try that again. Maureen Littman, in my dinner, an interest in a spreadsheet. There we go. Something totally weird. It sounds, you know, parts of this, Maureen Littman in, or even in my, could be a string that could make sense. In my dinner, N could even make sense. An interest in a, or even interest in a spreadsheet could make sense, but as a full string doesn't really make sense. So this is giving you a sense of the challenges within text generation as you're trying to make things more accurate, but dealing with, you know, sparsity of data. Some things to check out. You can learn about naive Bayes, classifiers, machine translation. We actually have some using, we have a unit on machine, well, it's on text generation that focuses on explaining text generation in the context of machine translation in order to showcase the use of LSTMs, which I mentioned earlier is that type of neural language model using neural networks. So yay, kind of fun. And I think that is pretty much it. We went through challenges and considerations already. Do folks have any questions?
No, I think everyone is fine. And it was a very engaging, I think, event, I would say. And thank you for showing us what goes on in Codecademy's NLP stuff. Would love to try out. Yes, you should.
Yeah, please do. And give us feedback. We love feedback. We love to hear about it. Tweet at me. Let me know what you think. I'm very into helping make our content better. So try it out. Let us know what you think. If you're curious about chatbots, this is actually a really fun way of exploring that topic. This starts from scratch, assuming no Python knowledge. So if you're even tentative about getting your toe wet, don't be, because you can actually get into using deep learning for natural language processing by the end of it, having come into it with no Python knowledge. So it's really cool what you can do with even just a little bit of coding knowledge. How much of linguistics and coding do you recommend having before going into NLP? You know, most people that I've talked to who've gone into NLP don't really have necessarily, like, a lot of times it'll be somebody coming from a math background or a linguistics background, some people coming from a computer science background, but a lot of the time it's just somebody who wants to make sense of some text data. And that might be somebody who's just a social scientist or somebody who's just trying to explore some, you know, a much larger data set. Could be somebody coming from the medical profession. So the truth is, you know, NLP uses a lot of foundations that exist within linguistics, but to get started, I don't think you need to be an expert in linguistics. You don't need to be an expert in code. You need to know some code, and I recommend Python because it's the easiest language to get started with for NLP, and also there are so many libraries that exist already for that support work in NLP for Python. But truth be told, please don't be intimidated. You can do a lot with very little linguistics knowledge, very little coding knowledge. And yeah, if you're excited about this field, please just get into it, dig in, try it out, have fun.
Thank you. Okay. Yeah, I would just say the same.
Oh, I'm so glad to hear that.
Great.
Thank you.
Yeah. Any more questions? Okay, we're getting thank you. Oh yeah. Oh, you've been using Codecademy for a month. That's amazing.
Fantastic. Avinash, have you tried out any of the natural language processing content yet? Has anyone gotten a chance to try it out? Is everyone just sort of like, oh, let me just, I'm kind of intimidated. I wanted to check this out before getting started. I completely understand if that's the case. It sounds like a much more intimidating field than I think it actually is.
Yeah, I think it's just too broad. And then when you're outside of it, you think about all of it like at the same time. And it's really intimidating. So
yeah,
just start from preprocessing.
Yeah, start preprocessing. Notice things about your text. It's fun. A lot of it is just exploring. You're just trying to explore, you're trying to find patterns, you're trying to, you know, and it is, I mean, to be fair, it is just a tool. It's one tool in your toolkit as you explore data. And as you try to do many different things, it is, there are a lot of different facets of, you know, text to explore, and it's a lot of fun. Thinking back to Turing's test, I feel like we can appreciate and understand human complexity in thought, speech, action even better when we try to replicate it. Absolutely, it is so true. I think this is actually something that really occurred to me when I used to teach English as a second language, because it's something where I have those built-in rules in my brain, right? I have this understanding of the way that English works. But as soon as I try to codify it in any way, as soon as I try to make sense of it and explain these rules to someone else, it just feels like so many things don't make sense. And I don't know why these, you know, everything works the way that it does. And I feel like it's the same thing as you're trying to build this into a computer and you're trying to tell the computer, hey, this is how you do X versus Y. And it's why we, you know, NLP at the very beginning might have been built on a lot of like if else statements, you know, if this, do this, if else, if like elif this, do this, but has really moved away from that because we can't just be as prescriptive, and it's much easier to say, hey, computer, try to find some patterns here because I don't really know how to find these patterns. And it's how you end up with those beautiful word embeddings in vector space where you can actually see the computer saying, okay, I understand that king and queen have this relationship to each other.
What blew me away in the like word2net, like, you know, in general, like the vectors, is that, for example, orange has two meanings, and then in the space like it's different. Like the words are different. Like one is associated with fruit and one is associated with the color, which was like, it's so cool.
Yeah. Yeah, that's a really great point, because it's sort of it sounds like the same word. I mean, if you ask an English speaker, they're probably going to tell you it's the same word, but it really is two different words because it's two different meanings. Yeah, so that's what I got today. I really, I think, budgeted mainly for 90 minutes. So hopefully this has been fun. I'm glad that those of you who mentioned stuff have had fun with this and learned a lot. And yeah, please go to Codecademy, check out the NLP content, tell us what you think.
Yes, Ahmed, exactly. Okay, thank you, Mariel. This was really great. Guys, I will email the GitHub link and the presentation slides, and maybe Mariel's Twitter, so you can, keep in touch with her. And yeah, see you guys on my Discord server. And yep, thank you for joining.
Bye all. Thank
Bye-bye.
you.